today's lesson is about irrational square roots. So the whole radical, the radicand won't be a perfect square. It won't cancel out to a perfect square. And we're going to learn how to deal with that. There's basically three things you can do when you're dealing with these irrational square roots. And it depends on what kind of answer you need. You can either estimate to the nearest tenth without a calculator, and I'll show you how to do that. You can find an exact value, which we will call leading to the simplest radical form. Or you can round it to a specified number of decimal places, and we usually do that with a calculator. We will be using a calculator on and off for the rest of the year, so make sure you do what you do. All right, so let's start to look at these different methods. The first thing is estimating the answer. So the first blank on your note sheet is one. We're going to talk about how you estimate the answer to these without a calculator. Basically, you got to think about all the perfect square numbers that you know, and I have a few of them listed here on the screen, and you have more of them listed on your note sheet. And if you're trying to find the square root of something like the square root of 53, this example we're using down here, you look for which two perfect squares it falls between, and then you try to find like at what decimal point it is by looking at the fraction of how far away it is from the lowest one. So let's just do this with the square root of 53. First of all, actually, let's back up a second, and let's just talk about, we can fill in these lines here the difference between some of these numbers, which can be helpful for you. So in other words, the difference between 16 and 25, that's 9. And the difference between 25 and 36 is 11. And the distance here is, the difference between these two is 13. And 15, it's always going up by 2 if you didn't notice that. And you could go ahead and fill that in through your whole note sheet. But those are helpful for us finding out where kind of exactly it falls between the two perfect squares. Okay, so back to figuring out how to estimate the square root of 53 without a calculator. Well, I look at 53 and I know it falls between 49 and 64. So I know my answer is going to be between the square root of 49, which is 7, and the square root of 64, which is 8. So I expect this answer to be between there, which means it'll be 7 point something. Well, and the way you can estimate that point part is look at how far away it is from the lower perfect square. So in other words, 53, the difference between 53 and 49 is 4. It's 4 numbers away. It's 4 out of, between 49 and 64, there are 15 numbers. So it's about 4/15 of the way between 7 and 8. And then that 4/15, you just want to approximate a fraction that's close to the decimal. In other words, some kids look at it as, well, that's almost 4 out of 16, which means it would be 4/16 is the same as 1/4. So some kids will say, well, that's about 7.25. And other kids will say, well, it's really close to 5/15, which reduces to 1/3. And we know that that's 0.33. So some kids might say that's 7.33. In either case, both of these to the nearest tenth would round to 7.3. And that's a really good approximation. If you do it on your calculator, you will see that when you round it to the nearest tenth, it would be this also. So you can get really close with this method. It's pretty clever. Shall we try another one? Sure, let's do that. All right, I have a number generator up here, and it wants me to find the square root of 107. So using the estimation technique, we look at the square root of 170, and we say, well, that's really close to, gosh, 169. Wow, that's really close to 169, right? So it's between the perfect square of 169 and 196. See those on your note sheet? So 169, the square root of that is 13. So this is going to be really close to 13. just guessing how close it is. It's probably just going to be 13.0 because of how close it is. But let's play this out. 170 is 1 away from 169. And between 169 and 196, there's 27 numbers. So it's about 13 and 127. 127, kind of the closest thing I can grab onto there is 125th I could do in my head, which is 400s or 0.04. So this one I would say is about 13.04, which, like I said, to the nearest tenth, I would treat it as 13.0. So that's how you use that strategy. It's a pretty clever way of estimating without a calculator. Again, that's without a calculator. Let's move on and look at the next strategy for dealing with these irrational square roots. The next one is when you actually have to find an exact value, and this is mostly what your homework involves tonight. Simplifying these without estimating and without using your calculator. So we're on the second page. The second method for dealing with irrational square roots is finding an exact value. That's what you put in your blank up there. If the radicand, that number under the radical symbol, is not a perfect square, the exact answer should be in simplest radical form. Those are your blanks there. The answer should be in simplest radical form. When you use your calculator, you're just estimating. And we're going to not do that now. Now we're going to put an answer in simplest radical form, and that would be a more precise answer. Looking at your note sheet, the blanks there, simplest radical form means that the radicand has no perfect square factors. That's what goes in those blanks. Radicands are neither decimals nor fractions. All right. So practice the directions, like on your homework tonight, will say simplify. And then you have to do something like the square root of 60. All right, not using your calculator, not estimating, putting it in simplest radical form. So what we do is we look at this radical, the square root of 60, and you break it down into a square factor and whatever other factor you can think of. So when I look at 60 and I try to think, can I think of a square factor of 60? Sure, 4. 4 times 15. Now 15 is not a perfect square, but 4 is. So the square root of 4, I can look at this as the square root of 4 and the square root of 15, and the square root of 4 is 2. Square root of 15 is irrational, so I just leave it. And my answer in simplest radical form is 2 radical 15, or 2 times the square root of 15. And that's it. That's how you leave your answer in this case. And that's an exact answer, all right? All right, let's try another one. That was the very first one you said. So we can generate another one up here. And I get the square root of 96. Okay. So if I simplify the square root of 96, I want to look at this and I want to ask myself, again, about perfect square factors. I break 96 down into a perfect square factor. And when I look at this, I know that 4 goes into it. 4 goes into it 28 times. Okay, and now, and I continue to analyze this, and I say, well, 28, though, it still has a perfect square factor in there of 4. I can break it down further, so I can break this down into the square root of 4, square root of 4 times 7. So really, this was, I didn't realize it initially, maybe you did, I didn't, that, ooh, okay. I think I have that there. 4, 4 times 28 is 100. That's what I did wrong. Sorry, let's backtrack for a second. 24. No wonder it was going wrong. Sorry about that. Okay, so this is 4 times square root of 24. And if I backtrack here, this is 24 can be further broken down into 4 times 6. Right, now it's making sense. So earlier, I should have realized that 16 was a factor of 96, but sometimes you don't. It's all right, though. So now I have square root of 4 times the square root of 4 times the square root of 6. So the square root of 4 is 2, square root of 4 is 2, and 6 is irrational. So I just leave it. This breaks down into 4 times the square root of 6. All right? Now, you could have done it up here. If you would have realized it, you could have just said, oh, the square root of 96 is the same as 16 times 6, in which case you would have gone right to 4 and the square root of 6. It's the same answer either way. One's just a little bit longer. All right, so that's a lot about what your homework is tonight. And then the third thing is you're asked to round to a specified decimal place. You can use your calculator sometimes. We'll do this later on with application problems especially. So when you're looking at your calculator, if you have the standard one, we recommend the basic keystrokes. The square root button is over the square button in light blue ink on the left-hand side of your calculator. So the way you access the square root button is by pressing the second function, the blue second function key. So if you want to do the square root of 376, you basically have to hit the second key, then you have to hit the square button, and that'll give you the square root function. You enter 376, and you press enter. And when you do that, your calculator will give you a long decimal string, but we're rounding to the nearest hundred. So for this one, you should get 19.39. Right? Same thing with the square root of 27. This one's a good one to look at, though, because when you do this, you end up in the situation where there's a 9 in the hundredths place, and when you round, you got to be careful that you still leave your answer with a digit in the hundredths place. So don't just give the answer of 5.2, you got to do 5.20 because of the hundredths place direction. And finally, try this one, and when you do, you should get 30.74. So there were 3 basic methods for dealing with these irrational square roots: estimating without a calculator, using simplest radical form, and then finally using the calculator. Your homework tonight will focus on the second method, simplest radical form.